All right, let's dive right in. We're going to talk about a process that, believe it or not, is behind almost everything, from life itself to our entire civilization. And look, this isn't just about making copies. It's about how anything at all, manages to stick around. This is the story of replication, the algorithm of survival.
And that really brings us to this huge kind of philosophical question. I mean, stop and think about it for a second. Why does anything last? We live in a universe that absolutely loves chaos and decay, right? So why isn't everything just random static? How does order or form or even an idea persist from one moment to the next?
Well, the answer is that there's this incredibly powerful force fighting back. It's a process that's actively pushing against that slide into disorder, what scientists call entropy. And this one single process is what builds patterns, creates complexity, and makes sure things continue against all odds.
And here it is. We call it replication. At its core, it's the mechanism that lets form, function, and information actually last over time. It's not just about copying, it's the active, ongoing algorithm of survival itself. So let's take a look at how this algorithm runs on a few different operating systems.
First up, let's start with the one we all know best, the place where this algorithm is most obvious. Life itself. This is the biological blueprint.
So what's so interesting here is the way we're thinking about a gene. It's not just some bit of a chromosome. It's the biological replicator. You can think of it like a tiny, self-contained packet of information whose only real job is to build a survival machine, an organism, that can protect it and then make more copies of it. And this right here, this is the grand purpose of it all. Life, at its very core, is just a system designed to replicate. It sucks in energy from the environment, not just to move around or grow, but to literally fight off decay and preserve the incredibly complex information that's packed into its genes. It's kind of like a rebellion against chaos.
So how does this whole thing lead to change and evolution? Well, it's this simple but incredibly powerful four-step loop. First, a gene replicates. A copy is made. But that copy isn't always perfect. A random error can pop up. Then, nature acts like a filter, and it selects the variations that happen to work best. And over time, the whole system adapts. The most important thing to get here is that the error isn't a mistake. It's the very thing that drives all innovation.
Okay, so that's biology. But what if I told you this exact same algorithm is running somewhere else, somewhere way more abstract? Turns out it's also how our ideas, our beliefs, and our entire culture spreads. This is the cultural echo.
This is just such a powerful analogy, right? In biology, the replicator is the gene, and it gets passed along through DNA. But in culture, the replicator is the meme, and it gets passed along through imitation. The algorithm is the same. It's just found a brand new host, our minds.
And look, when we say meme, we're not just talking about the funny cat pictures on the internet. In its original, scientific sense, a meme is any piece of culture that can be copied. A catchy song, a fashion trend, a scientific theory, a religious belief. It's basically an idea that knows how to get itself copied from one mind to another. And the way it works is, well, it's almost identical to biology. The meme is the replicator, it's transmitted through communication, and it uses our minds as the host. So what's the selection pressure? Our attention, our belief. Ideas are literally competing for real estate inside our heads, and the ones that are the catchiest or the most useful or just the most compelling, those are the ones that survive and build what we call culture.
Okay, so from genes to ideas, let's bring this right into our world, right now. Because in the information age, this algorithm has found yet another new home. This is the digital echo.
The virus, and this is true for both a biological one and a computer one, is the perfect example of replication in its absolute purest form. I mean, it's stripped of everything except one core instruction: make more copies of me. It's just pure replication code that hijacks a host, whether that's a cell or a computer, to keep its own informational lineage going.
And once you start seeing this pattern, you see it absolutely everywhere. Every single time you hit save on a document or back up a file, you're doing an act of high-fidelity replication to fight against data decay. And then, at the really far end of the spectrum, you've got things like self-replicating AI, the dream of machines that can reproduce and evolve all on their own. This all leads to a really fascinating, almost sci-fi idea: the theoretical universal replicator. Just imagine a machine that, if you gave it the right raw materials and the right instructions, could build a copy of anything, including itself. It's the ultimate expression of this whole principle, tying together biology, computers, and even physics.
So let's zoom out one last time. Let's look at the grand rules that seem to govern this entire process, the universal principles that allow anything to persist through time.
You know, at the heart of all this, there's this amazing creative tension. For anything to survive, it actually needs two opposite forces. It needs fidelity, the ability to make a really precise copy. That's what gives it stability and identity. But it also needs error. It needs random mutation to create new things and adapt to a world that's always changing. Too much fidelity, and you stagnate. Too much error, and everything just falls apart into chaos. It's all about that balance.
And check this out. This table just lays out the entire pattern perfectly, across every single domain we've talked about. In the biological world, you've got genes using DNA to make sure life continues. In the cultural world, you've got memes using language to build civilization. But each one has a failure mode, right? Disease, data corruption, misinformation. That's what happens when the replication process goes wrong. It is literally the same story, just told in 4 different languages.
So when you get right down to it, replication is kind of the fundamental grammar of our universe. It's the set of rules that explains how patterns hold themselves together, how complexity gets built, and how any kind of identity is carried forward through time.
You know, the source material puts it in this really beautiful way. To replicate is to remember, to embed identity into time. Every single act of replication, whether it's a cell dividing or you sharing an idea with a friend, is an act of memory. It's pushing a pattern into the future.
And all of this leaves us with one last, pretty important question, because we are all part of this process every day. We're the ones who choose which ideas to share, which values to teach our kids, which information to save. So if replication is what defines what survives, what are we choosing to copy into the future?